Baker Day, Operation Crossroads, Bikini, 1946. November 1948, more than 2 years later, and this explosion is still making headlines. Stories about the insidious, invisible, dangerous radioactivity resulting from an atomic detonation. There were then, and still are, many unanswered questions about atomic energy. In seeking the answer to some of these questions, let's go back even farther. Back to Japan in the summer of 1945, when the military application of this force was first employed against the cities of Hiroshima and Nagasaki with such devastating results. Fury of destruction descended upon Japan, which unquestionably speeded the end of the war. Immediately after the surrender, our survey teams were picking their way through this rubble, analyzing, questioning, making measurements, and seeking the exact causes of the great loss of lives, many of which apparently occurred outside this area of concussion. Here, for the first time, the question was raised: could not a great many lives have been saved had efficient evacuation of wounded been accomplished before the ensuing fires? Many answers to the radiological questions raised in Japan were found in the laboratories set up within the United States. Here the reports and findings of our survey teams were studied and analyzed. From these studies, it was determined that injuries due to radiation were primarily those occurring within the first second after the explosion. It was definitely proved that there were no casualties resulting from either scattered fission products or induced radioactivity from contaminated objects. Here as well, research and development work went forward to improve instruments necessary for the further study and detection of radioactivity and its effects. Portable survey meters, personal dosimeters, and countless other instruments designed to indicate when hazardous contamination is present or when dangerous overexposure is imminent. Special schools were established to intensify the study of radiological safety. Staffed by top scientists and medical men, these schools trained selected students from all branches of the service for radiological safety missions. The setting for the first was provided by the establishment of the Atomic Energy Commission Proving Ground at Eniwetok. The mission itself, the responsibility for the radiological safety of more than 10,000 people engaged in Operation Sandstorm. The testing of 3 improved atomic weapons. In numbers of people, the RadSafe problem is comparable to that of an average American community. In area involved, the problem is many times more complex, due to the extensive experimental program to be carried out. This group must affect radiological safety support of all operations in the radioactive area, enforce radiological safety regulations, detect and determine the intensity and type of radiation encountered, organize and supervise any required decontamination of personnel and equipment, establish and maintain a system of permanent records on all personnel exposed to radiation. Concurrent with operational planning, primary construction was going on at the test site. The time scale was short. The convoy bearing highly trained scientific and technical personnel begins its long journey to Eniwetok. In the Radiological Safety Operations Center aboard the Mount McKinley, planning continues. The staff has established the maximum individual dosage of radiation at 1/10 Roentgen per day, and through the use of proper equipment and precisely recorded data, can check the exposure or overexposure of any person or group in the operation. Aboard the Bairoko are the many units of the Radiological Safety Group. The monitor unit will provide personnel and equipment for safety escort in connection with work in contaminated areas. The Radiological Records Unit will maintain complete exposure history on all personnel. It will prepare recommendations and reports and make permanent records concerning all exposure and overexposure. The Laboratory Unit will repair and calibrate instruments, develop and interpret personnel film badges, measure decay rates and extent of hazard from all radioactive materials. Frequent briefings knit the unit into a smoothly working team. Although many of the men have never witnessed an atomic explosion, others are veterans of Trinity, Hiroshima, Nagasaki, and Crossroads. For all, however, the responsibility is a heavy one. The arrival of the convoy at Eniwetok steps up the tempo of activity in the lagoon. RadSafe men lose no time in getting ashore to begin work on their own installations. The basic construction of the test site is complete. The placing of scientific instruments and equipment moves rapidly ahead. On Zero Island, the emplacement of radiological research material and equipment is proceeding along with other scientific installations. Sealed packets of film for recording radiation are placed in special steel racks. Along with materials to measure the thermal effects of the detonation, there are placed simple crystals, which assume characteristic colors when subjected to different amounts of radiation. Other film packets are placed between special shielding materials. All these installations serve a number of purposes. Not only do they detect radiation, they tell how strong it is at different distances from the detonation point. They detect the nature of the particles and type of radiation, alpha, beta, gamma, or neutrons resulting from atomic fission. They all serve to show the effectiveness of certain shielding materials. A cascade impactor is installed to gather data on particle sizes. How does radiation affect biological material? To find out, samples are wrapped in glass wool for heat protection and placed where they will be subject to radiation. On the Bairoko, the tedious checking and rechecking of survey meters goes on. A small amount of radium, a source of known intensity, is placed at the center of arcs measured off at various distances from this center, and the meters are calibrated against this known source. The meters are tested in pairs so that one may act as a check against the other. Meanwhile, members of the monitor unit in Kwajalein are plotting anticipated fallout of radioactivity. Downwind from the point of detonation, an airborne radioactive hazard will exist. Its characteristics and path will be determined by the direction and speed of wind at the various altitudes attained by the cloud. The possibility of unpredicted wind changes and the ensuing radioactive hazard must be taken into account so that all islands in the Marshall Group are included in the safety plan. In this climate, meters must be stored in special air-conditioned vaults as a protection against the effects of tropical moisture and fungus. Although of several different types, these meters are all used for essentially the same purpose. the detection of the various types of radiation, and the measurement of intensities. The checking and calibration of meters to ensure their proper operating condition is continuous. Dosimeters are zero and prepared for recording even the most minute amounts of radiation. Constant maintenance is performed to ensure proper functioning. No detail is too small. As zero time approaches, the radiological safety plan assumes control. The island installations are complete. The evacuation of personnel to points of safety moves swiftly. Ships in the lagoon withdraw. Aboard the Mount McKinley, prevailing conditions are reviewed in the radiological operations section before presentation to the task force commander. While on the Bairoko, last-minute briefings are prepared for the monitors whose task it will be to administer radiological safety, as well as to gather samples and make on-the-spot surveys of the radiological situation. Prior to their final briefings, the monitors have changed clothes. All personnel have been issued disposable clothing, which, as an added safety precaution, may be discarded in the event of radiological contamination. Everything is planned and plotted. Communication systems for monitors in the field, wind changes, predicted fallout of radiation, and above all, safety precautions. These must be explained, checked, clarified. So the final briefing begins. Meanwhile, monitors brief air crews and issue equipment. Film badges are issued to all personnel who will enter radioactive areas, and a careful check and record made of each issue. Monitors conclude their final briefing and then draw the remainder of their equipment. Canvas booties, gloves, film badges, dosimeters, gas masks, detection meters. All data concerning equipment issued is carefully entered in personal records. Zero Island and its surrounding waters are deserted. Night closes in, and the hours of tense waiting begin. The drone planes warm up. They begin their takeoff as the time of detonation approaches. shortly before dawn. 0 hour. Zero Island, blasted, torn, twisted. First over the area is a helicopter, bearing a RadSafe monitor to take readings on the radioactive area. Drones fly through and around the cloud, taking samples for later analysis. The B-29 cloud trackers approach the radioactive mass, making observations and reports on the movements of the cloud. By this time, reports coming back to the ships indicate that it is safe to move in closer to the island. And the monitors prepare to go ashore for on-the-spot surveys. Other monitors must check and clear the lagoon before ships enter the area. The first party cautiously lands at the tip of the island, the spot most remote from the center of the explosion. And the monitors begin their cautious approach to the detonation site. With an assurance born of confidence in their training and reliance upon their detection equipment, these men move on to more contaminated areas, measuring, collecting samples, making surveys of the destruction. And acting as safety escorts for other personnel on the island. Helicopters stand by for any required rescue operations and to speed delivery of samples to laboratories aboard ship. Samples are checked in precise and accurate laboratory models of radiation detection instruments to augment reports coming in from the monitors. Working closer to 0 point, the monitors wear gas masks as a precaution against ingestion of noxious material. In other areas, the earth is turned over for sampling. Constant radio communication with the control center provides up-to-the-minute information on the radiological situation and the data for charting the decay of radiation around 0 point. Through intelligent use of radiation detection equipment, some of the personnel are aware that they have now been exposed to radiation for the maximum period of time consistent with safety And as they return from the contaminated area, they are again monitored as an additional safety check. They turn in their equipment, film badges, dosimeters for a final check. All contaminated clothing is discarded and prepared for disposal. More men return for inspection and turn in film badges. Here, the careful process of checking and recording the records of each man is continued. After initial paperwork is completed, film is delivered to the laboratory, developed, and delivered for densitometer analysis to determine the amount of radiation to which the film badge and its wearer have been exposed. Again, the individual records are examined, and each man's history of exposure to radiation is carefully recorded. Meanwhile, samples continue to flow into the laboratories. The long-range scientific plan and research in the field of radiation and radiological safety is now beginning to supply positive answers. Here, an impactor slide is inspected for particle size analysis. Back on the island, the surveys continue. Even blackened and burned tree stumps are inspected for hidden traces of radiation danger. Vegetation and flowers at remote sites from 0 point show evidence of scorching and must be checked for induced radiation. Flies and other insects here appear to have survived without ill effect. In some areas, the feathers of dark-colored birds were singed. These birds were unable to fly. The lighter-colored birds flew away without injury. Even on any island, far removed from 0 point, the area must be monitored as film recovery teams approach a photo tower. On Eniwetok Island, scientists and drone plane maintenance personnel prepare for the return of the pilotless aircraft. Their mission complete, the drones return with their samples. Having repeatedly flown through the atomic cloud, these planes must be approached and handled with extreme caution. Sample filters must be removed immediately. Although unanticipated, this operation involved the highest radiation levels to which any personnel were exposed. After the samples have been removed, the decontamination of the aircraft is supervised by RadSafe. When individual tolerance limits of radiation exposure have been reached, this means replacement and off to the Personnel Decontamination Center. Here, the energetic application of plain GI soap and plenty of water is administered under the supervision of the ever-present monitor. The last group of monitors leave X-Ray Island, their work here completed. Back to the Bairoko comes the last helicopter. All areas have been checked. Lagoon waters have been cleared. The post-detonation phase for X-ray has been accomplished. So as preparation for Y and Z blasts are finished, there is born a new confidence and assurance inspired by the knowledge that radiation, when handled intelligently, can be handled safely.